All right, in today's lesson, we're going to be going over inequalities. Up to this point, we've been focusing on equations. And equations, what makes something an equation is an equal sign. Well, inequalities are kind of the opposite of that, okay? Inequalities are comparing things that are not equal or unequal. And to do that, like we have different symbols. The most basic one's probably the equal sign with a line through it, which just means not equal. And then the other ones that you're probably familiar with are the less than symbol, and also the greater than symbol. And of course, I could also throw a line underneath those. So like that would be less than, and I'll just put this in brackets, or equal to, if you have the line underneath it. Or you could have a greater than or equal to. So what you need to know is, like, first of all, how do you graph one of those on the number line? So if I had just wanted to show, x equals 1. Let's put it on the number line. Well, I would go to 1, I'd put a dot, and we'd be good to go, and that's it. If you're doing inequalities, though, an inequality has an infinite number of has an infinite amount of numbers that make it true. For example, if I did show me all the x values that are greater than, we'll say 4. Okay. Well, I'm going to go to 4. Now, I don't want to use 4 because 4 is not greater than 4. So I don't actually want to use the number 4, but I could do 4.1, or I could do 4.001, or I could, as long as it's just a tiny bit above 4, it's going to make it a true statement. So the way that you show that is I would go through and on my number line put an open circle at 4. Okay, and that shows that that's kind of where it starts, but I don't include that number. And then I just go off to the right, because these are all the numbers that are bigger than 4. 5, 6, 7, 8, and so on. So that's what x is greater than 4 would look like. Now you could also go in the other direction. So I could say x is, we'll say, less than or equal to, -3. Now because it's a less than or equal to, well then, instead of putting in like an open dot like I did on the other one, I'm going to go ahead and take that open dot and fill it in. Because now, actually, I could put -3 into that, and it would be a true statement. And if I want to do everything that's smaller than -3, well, that means I'm going to be going to the left on my number line, because those are all the numbers that are smaller than it. So that's how you graph an inequality. So now let's take a look at how you actually solve one. And I'm going to start with our work that we've done with equations, because equations are something we're familiar with at this point. And, I could go through and I could solve this. I could add 5 to both sides. That would give me x over 3 is equal to 3, and multiply both sides by 3. And we get x is equal to 9. Okay, and I could take that as my answer, and I could prove that it's true by plugging it back into the original equation. And that's great. Now, how you actually go through and solve an inequality is identical, okay, with one exception, which we'll talk about in a second. But in inequality, I'm just going to replace that equal sign with, in this case, a greater than sign. And instead of having just one answer, I'm going to have an infinite number of answers. But how I actually solve it is exactly the same. In fact, I'm so lazy, I'm not even going to write it down. I'm just going to take that work, copy it, and I'm just going to move it right over to the inequality. The only thing that is different is instead of using the equal sign, I need to take that and I need to replace it with a greater than sign. So for this one, my answer is going to be all values that are greater than 9. So as long as x is bigger than 9, it's going to be a true statement. If I wanted to show it on my number line, I would go to 9. I'm going to use an open circle because it's greater than, not greater than or equal to. And then my arrow, I don't have a whole lot of room to work with here, but it would be shooting off to the right. And if I wanted to check and see, is that arrow going in the right direction? Well, I would pick a number that's bigger than 9. So let's say here, we're going to check, and let's use x is, I'm going to pick a multiple of 3, so it divides evenly. I'm going to pick 12. Okay. So let's try that out. I'm going to do 12 divided by 3 minus 5, and we're going to see, is that greater than -2? Well, 12 divided by 3 is 4. 4 minus 5 is -1. -1 is greater than -2. It works. We're happy. That means our arrow is probably going in the right direction. What you don't want to do, you don't want to actually pick the number 9 and substitute that in. And I know we're used to doing that when we're solving equations, But when we're solving inequalities, we're checking to see, is the arrow pointing in the right direction? And if you pick 9 where it starts, that's not going to tell you if the arrow is pointing in the right direction. So we always pick, sometimes I'll call this our test point. Like we're checking to see, is that part of our, what is sometimes referred to as the solution set. Yeah, we say solution set because there's an infinite number of possible values, and we just want to see like 12. Is that part of that infinite number of values? All right, so that's how you solve and graph an inequality. So what I'd like you to do is take a moment, try this yourself with the inequality 5x plus 2 divided by 4 is less than or equal to -2. All right, so hopefully you're able to solve that. The correct answer is x is less than or equal to -2. And you can see the steps there on the paper. What I would want you to do next is, if I was going to ask you to graph that on the number line, which of these choices would it be? And yes, the correct answer is choice B. It's going to be choice B, okay? Because the way you would read this, x is less than or equal to -2, so it's going to be pointing to the left. And I'm going to use a closed dot at -2 because it's less than or equal to. So choice B is my correct answer. The one exception, I said when you solve these, it's exactly like solving an equation. There is one exception to that, and let me show you what that is. If we were going to solve this, think about your inverse operations and how you'd solve it with an equation. I would, start by taking 6 away from both sides, and I'd be left with -2x is greater than or equal to -8. And then I would divide both sides by -2, and that gives me x is greater than or equal to 4. And you might be thinking like, yeah, okay, no problem. So I'd go to 4, put my closed dot, and then I want to make sure that my arrow is going to be going to the right because it's everything bigger than or equal to 4. And if I wanted to check this, I need to take a number that's in my solution set. So what's a number that's bigger than 4? Don't pick 4. So I could take any of these numbers up here, 5, 6, 7, 8, any of those is fine. Let's use 7. So I'm going to plug that in. 6 minus 2 times 7 is greater than or equal to -2. So that would be 6 minus 14 is greater than or equal to -2. That works out to be -8 is greater than or equal to -2. Uh-oh, wait a second. -8 is not greater than or equal to -2. Like you can just see it on the number line. Here's -8, here's -2. Clearly negative 8 is not bigger than -2. So what did we do wrong? Like it's good to go, you'd go back and check your algebra. Did I graph the line wrong? But what happened was, there's a little rule you got to remember, and it pops up right here. And so you see what we did in this step is we divided both sides by -2. Now, what the rule is when you're working with inequalities, anytime you divide by -2, you have to take that inequality sign and you got to flip it around. So that inequality sign it was starting as a greater than symbol. Well, now it's going to become a less than symbol. And so what I should have done is when I graphed it, my line, let me erase the line going to the right, because the actual answer is going to be all the values that are less than or equal to 4, not greater than or equal to 4. And same thing, when you plug that a point in. Now, I wouldn't pick like before, I picked the number 7, right? But 7 is up here. Okay? Now when I flip my line around, let's pick a number that the arrow's pointing to, not to 4. So let's pick, 0 is always a nice one to work with. So instead of plugging in 7, I'm going to plug in 0. So I'm going to put 0 here, which is 6 minus 0, which is just going to be 6. And our inequality sign, and you see like the inequality sign when I started was greater than or equal to. So it should be greater than or equal to here. Here, oh look, 6 is greater than or equal to -2. So that tells me now my arrow is probably pointing in the right direction. So what I'm going to leave you with is I want to make sure that you know why that inequality sign switches. If you think about it, like if I take two numbers, like say I take 1 and 2. I mean, clearly 1 is bigger, or sorry, 1's not bigger than 2. Clearly 2 is bigger than 1, right? And you could see that if I did a quick little sketch on a number line here. Here's my 0, here's my 1, and here's my 2. And oops, And here's my 2. And 2 is further to the right. And whatever is further to the right is the bigger number, right? That's how number lines work. Well, if you took the 1 and 2, and let's say I took both of these and I multiplied them by -1, okay? So I'm going to multiply both of these by -1. And with the 1, when you multiply by a -1, it's going to become -1, and the 2 is going to become -2. And if you think about on the number line, well, the -1 is there, -2 is there. So when I multiply them by a negative, really what it has the effect of doing is it takes that positive number and it flips it over onto the negative side. And it took my 2 and it flips it over to the negative side. Okay, but what happens when you do that is before, because 2 was further away from 0, when I flip it over, now instead of being further to the right, it's further to the left. And remember, this is still true. Like whichever number is further to the right is the bigger number. And that's also true on the negative side. But when I multiply by -1, it switches the signs. But so now, instead of the -1 being the smaller number, the -1 becomes the bigger number because it's further to the right. So that's why whenever you multiply or divide by a negative, the sign switches directions. It's because the number that was bigger becomes the smaller number and vice versa.